Matrix inverses. An important part when dealing with inverses is to know what the identity matrix is. The identity matrix is different depending on the dimension. So, if we had a 2 by 2 matrix, the identity matrix would be 1, 0, 0, 1. If we had a 3 by 3 matrix, the identity would be 1, 0, 0, 0, 1, 0, 0, 0, 1. What makes it the identity matrix is the fact that going from left to right, top to bottom, there's a diagonal of the number 1 and all other entries are 0. So if you made a 4 by 4, you would have 4 ones going diagonally down, and then every other entry would be 0. So let's take a look how you use the identity matrix. So essentially, if I'm given the matrix R, then if I were to take R and I were to multiply it by capital I, which represents the identity matrix of the same dimension, so it would be the identity matrix of a 2 by 2, then you would get R. And also the reverse. If you took the identity, you multiplied it by matrix R, you would also get R. So the identity matrix is essentially the number 1. When we take a number and we multiply it by 1, we get that same number. Now, the inverse of matrix R would be denoted by R to the negative 1, like you've seen in functions. So what does this mean? This means that the original times its inverse will equal the identity matrix. Just like with functions and numbers, the original times the inverse gives you 1, for instance. Now, if I gave you 2 inverses and I asked, are the following matrices inverses, what you would do is you would do G times, it's a multiplication sign, G times C, and you should get the identity matrix. So go ahead and try this in your calculator and see if you get the identity matrix, and since it's a 2 by 2 times a 2 by 2, the identity matrix that we should get is 1, 0, 0, 1. Now, when you plug that in your calculator, you do get 1, 0, 0, 1, so yes, they are inverses of one another. If you didn't get the identity matrix, and I mean exactly as you see it here, nothing switched, even if they're all 1s and 0s, it doesn't matter, it has to be in that order just like that, then you would simply say they are not inverses of one another. To find the inverse, you need to know what the determinant is. So given the matrix A, B, C, D, as you see here, the determinant takes the first diagonal and is A times D and subtracts it from the second diagonal, B times C. So after you do this subtraction problem, it gives you the determinant. So what does that mean? Well, given the function, or excuse me, the matrix A, B, C, D, like stated before, to find the inverse, you do 1 divided by the value of the determinant multiplied by a new matrix. Now, this matrix is a little bit tricky. You take A and D and you simply switch their places, so you have D up here and A down here, and B and C stay, but you just take the opposite of them. So essentially what you do is you take A, B, C, D as a matrix, you flip D and A, and you change the sign of B and C. Then, after you find the determinant, you put it underneath 1, so it's a fraction maybe in some cases, and then you do scalar multiplication to the new matrix shown right here. So that is essentially how you find the inverse. Now, again, we're going to be using our calculators, but this is still good to know so that when you get something crazy in your calculator, you can verify and know that it is correct. So when you complete the problems on that first note sheet to find the matrix, what you're going to do is you're going to enter in, let's say, a 2 by 2 matrix, and just like you know how to. And then what you're going to do is when you go to second matrix and you choose A, let's say you put it in matrix A, then you hit enter, and on your screen you're going to have the little matrix box with A in it. Then what you need to do is hit the -1 sign. Again, this is the symbol that represents the inverse of A, matrix A. So while you complete these problems, this is what you're going to do. When you hit enter, it's going to give you the inverse matrix. And if you want to know if you're correct or not, you can, again, in your calculator, take matrix A, go back in again, pull matrix A again, but add the -1 to it, and you should get the identity matrix. The last thing to note is the fact that not all matrices have inverses. So how do you know if it has an inverse? Well, it's all in the determinant. A matrix has an inverse if the determinant, which is AD minus BC, does not equal 0. Then it has an inverse. So what I would do before finding the inverses in your calculator and taking up that time is quickly do or find the determinant if you can. And again, we've only usually do the determinant in our heads with 2 by 2 matrices. So if there's an example that's a 3 by 3, then you are just going to have to use the calculator and see if it says error or not. So if it says error, then you know that it doesn't have an inverse, assuming everything else is correct. So a matrix is, if this is true down here, and you can find the inverse, then we call this matrix invertible, meaning the inverse can be found. And again, remember, not all matrices are invertible.